Hello, and welcome to Shane's Microscope. I'm Shane, and this is my microscope. Let's take a peek. Today's sample comes to us from my finger. So I've got one of these home blood sample collection kits, and I figured I'd keep a little bit for myself to investigate. After cleaning off the end of my finger with an alcohol solution, I used one of these single-use lancets to give myself a prick, and I figure we could take a look at what's in there. Let's look at this blood. Blood is a Germanic word simply meaning blood. You'll notice here I've got some skin cells contaminating my blood sample. This is why labs prefer to get blood out of your veins to avoid that kind of contamination. Here at high magnification, we can see that the blood cells indeed have that sort of characteristic donut shape. This looks kind of like a bowl of SpaghettiOs or Cheerios, and you might notice in here among the blood cells that we've got these stacks of them. Those are called rouleau structures, and that just comes from the French word for roll. It's something that you see as the blood starts to clot because it's an efficient packing structure for them. Now, red blood cells are scientifically referred to as erythrocytes. That's from the Greek erythros for red and kaitos for container. Now, you can probably also notice that these red blood cells don't really have a whole lot to them aside from their distinctive shape, and that's because they lack nuclei. They don't contain the genetic information required to make other red blood cells. Your body makes those in the bone marrow. So these lack cell nuclei like other mammal red blood cells, and one of the theories there is that it allows for maximum hemoglobin storage in the minimum amount of space. There's no need for the red blood cells to be able to do anything other than transport hemoglobin. And hemoglobin has a mixed heritage. It's got the Greek hema for blood and the Latin globus for a ball or a sphere. And that's the protein that's packed into the red blood cells that allows them to transport oxygen. It's got a little bit of iron in there that has a strong affinity for oxygen, and that allows it to shuttle that around your body. Oh, that's really interesting. As the blood moves towards the area where it's starting to clot. So just for fun, I decided to play with a little bit of oblique illumination on these. So this is the blood cells illuminated from the side. Gives us a feeling of depth to the cells, a sort of three-dimensional structure to them. Also, here at higher magnification, you can see that they're almost casting little shadows. And then, just to wrap things up, I figured I would look again through my various magnifications at the blood now that it's had a chance to clot a bit. You can see that the blood cells have definitely clumped together. And at the high magnification, you can see that the red blood cells have coagulated to the point that a lot of them we can't even tell apart now. They've merged to form that protective scab like they're supposed to. Alright, well, I think we'll leave it there for the day. Thanks for having a look with me. Until next time, keep on peeking.